introduce our guest speaker. Raffi Krikorian is here from Twitter. And if any of you would like to work at Twitter, we have some opportunities. I'm sure they have some opportunities they'd be happy to talk to you about. Here's Judy from Twitter, Judy Can Wave. So if you're actually really excited about that, you say, oh my God, my life dream is to work for Twitter, talk to Judy afterwards and make sure you let her know your contact information. Before I yield the podium, I want to make sure you know about a midterm, our midterm that's happening 1 week from today in the evening. That's 6 to 8 p.m. It's going to be in 10 Evans. People have asked what's going to be on it. It'll be half programming and half non-programming, like all the other exams we're going to have. This class is about half and half programming, half not, just like all of our exams as well. Question? What day is it again? It's Wednesday. Wednesday, a week from today, so Wednesday, 6 to 8 p.m. Question? So for those of us with the lab from 4 to 6, we're going straight to a midterm after? Correct. For those of you with the lab from 4 to 6, you might want to get out like a little bit early from the lab and take a break and get some food and then come back to the exam. But yes, that's when we got the room. That's all they give us the room. And we'll be a review session this weekend, and maybe Luke will let us know when that is. It's online. We'll make sure that all the information is online and maybe emailed to you as well. But it's this weekend, and you can ask all your questions you have there. Again, welcome around. Let's give Raffi a hand.
Hey guys, my name is Raffi Krikorian. I run what's called the Platform Services Group at Twitter. So who knows what Twitter is? Who's used Twitter? Anyone? Who has an account? So not enough of you. That's fine. So let me just explain what I do, where I came from. So I'm an MIT grad. I came to Twitter about 15 months ago at this point. And the Platform Services Group are the people who run the core logic of Twitter. So there's really only 3 things we care about at Twitter. Everyone else in the company is going to hate me when I say this, but it's sort of the users, the tweets, and timeline, so like the list of tweets. And all those, that business logic, all the delivery of that, all the presentation of that comes out of my team. It's about 12 engineers on my team. We're growing very fast because we sort of need to keep up with user growth on the system, but that's basically all we do. There are other teams in the company that handle things like the web client. So those of you who use Twitter, we just relaunched a new website. That comes from the web client team. There's a mobile team that builds all the like Twitter for iPhones, Twitter for BlackBerry, Twitter for Android. There's an internationalization team. There's a team that handles our geolocation stuff. There's a team that handles our promoted product suite. But then again, like my team just handles like the core infrastructure of what makes Twitter do what it does. So I guess to start with, what's a tweet? So I think the best way to sort of kick this off is for those of you who actually use Twitter, if you want to try following me, for those of you who don't use Twitter by mobile phones, if you just send an SMS to 40404 with follow Raffi, then you should just sort of get a tweet. I'll give you a few minutes and then I'll queue up one on this side, and then we can talk about it for a sec. So have people done it? If any, I'll send it anyway. So what that does, and for those of you who are hopefully following me, is that we've just queued up a tweet in the system. Well, I'll go through the rest of this lecture is sort of like the life cycle of that tweet, like how the system actually works and how my phone sends a tweet in the system and how it gets out to everyone's mobile phones or everyone's devices in the end. But really, to really just sort of kick it off, like everyone sort of knows what Twitter is. Everyone has heard it in the press. But I guess it just helps a bit to talk about our history and sort of like where we stand in the world. This is what really got me most excited about Twitter, is sort of when I did my interview process, everyone asks you, I'm like employee number 50 or something like that, and everyone asks you when you're interviewing, like, why do you want to join Twitter? And the 2 things that I sort of mentioned are the 2 things I'll cover here is Twitter's in a unique place in the world in that everyone knows who we are, everyone knows what we do, and everyone understands sort of the importance of what we're trying to accomplish in the world. Like we're trying to build an information network that allows anyone to get access to anyone else's information. But at the same time, we have massive engineering challenges I'm going to try to impress upon you as we go forth. But so this is really the canonical example of what we sort of kick off with. So there's James Buck is a story we like to tell. He's a journalist who traveled to the Middle East around 2008 to follow protests that were going on there at the time. And he would always show up to protests late. Like he would just be going around and trying to figure out what's going on, where are these protests, how can he cover them, how can he take pictures of them. And he would always get there like an hour or two late after they've already disbanded. So he started asking around, like, how do you find out where these protests are happening? How are people coordinating amongst themselves? And they all actually said the same thing, basically. It's like, we're using Twitter. Like, we send out a message, and then we just create, like, a flash mob or whatever you want to call it. They'll converge around where that tweet was sent from to actually handle our protest. So he started using Twitter. He started following what's going on at all these events. He started documenting it correctly. And then one day, he sent one tweet saying that he was arrested trying to cover an event that was going on. This sort of shows off, I think, what's the power of Twitter is that one tweet was then picked up by people at UC Berkeley, where his friends were. It went up to the dean of students, who called the State Department, who made a phone call. And then, so this is April 10th, that one tweet sort of triggered a series of events that caused on April 11th him to send another tweet out saying that he was freed. So there's the ripple effect of what goes on in the Twitter ecosystem is actually pretty amazing. So this is one person. You have bigger events that sort of go on in the world, things like Haiti and things like Chile, where earthquakes and big, huge catastrophes cause people to tweet, not just to send out information of what's going on around them, but for people to sort of talk about, send condolences, for people to ask questions, for people to try organize information around it. People really just trying to understand what's going on in the world. And that's really what Twitter kind of is. It's a way for the entire world to have a conversation without necessarily barriers of who's a friend of who and who do you like and who are you willing to see your status updates. By default, everything you say on Twitter goes out to the world. Unless you explicitly choose not to. That's sort of the name of the game when you sort of create a Twitter account. And then people use this as a mass communications medium to just sort of converse. We have some other good examples in popular culture. So the VMAs this year had a big, huge Twitter visualization running during the VMAs. And there was a call out for people to start tweeting about their favorite celebrities. And we were tracking how many tweets a minute were showing up with certain hashtags. We even sponsored, sponsor is the wrong word, we even asked people to tweet hashtags like, what if Bieber met Gaga, for example, and just really try to get the conversation flowing in the system. And then the Emmys, Jimmy Fallon asked people to tweet in introductions that he would then read on air to have people come down the red carpet with. So again, we're just in this really unique place in the world where we've created a communications mechanism. We've created a channel. It's almost a utility for people to talk in ways that are not possible before. You can sort of jump the social graph, or you can jump any social norms and sort of reach out to anyone you really want to. And it all really started as just a simple sketch that one of our co-founders put together, where he was imagining a world where you would share your AOL away messages, for example. So like when you're away and you're like, I'm out to lunch, or I'm going to see a movie. That was sort of the beginning and the genesis of what Twitter was. In fact, Twitter in the beginning was only destined to be a mobile phone platform. It was only going to be people SMSing each other. And that's really still core at our roots. We really try to cater to make sure that the lowest possible devices can still participate in a global network. In fact, that's the real reason it's 140 characters. 160 characters is the SMS limit. So we reserve about 20 of those characters for usernames and 140 a text. This means that any device in the world that can send an SMS, so any mobile phone in the world, can participate in the Twitter network. And you have great stories of farmers in sub-Saharan Africa who use Twitter to figure out what are the prices of their livestock going to go today, so to determine whether or not you should bother going to the market. We have deals in India where tweets, so normally you pay for incoming SMSs, whether it be 5 cents, 10 cents in the US. We have deals in India on certain carriers where incoming tweets are free. So you can get as many tweets as you want. They'll come as SMSs to your mobile phone. You don't have to pay for them. You only need to pay to send the tweet up into the system. So people are using that to deliver healthcare information because we've now become this interesting communication mechanism to get that world out there, to get that voice out there. So I guess like the crux of what we're going to try to talk about now is how does Twitter actually work? Like how do we do our thing? So for those of you, and you should interrupt me at any time, because I don't necessarily know what level I should target at. So Twitter, in reality, is only 3 things. So we're a struct. A struct is a kind of a data structure, like how you sort of hold information together. We're a graph. By graph, I mean how people are interconnected in the world. And we're a list. So our tweets show up in a list form. So that's really all Twitter is. It's 3 very simple data structures. There's nothing else really complicated about it. Like, we don't natively do pictures. We don't natively do anything else. We're just about sending tweets to people and putting it into a list for them to read later. So a tweet is a really simple thing. It's 140 characters. The question I usually get asked a lot, since I'm one of the leads of teams that deal with tweet delivery and tweet reception, is how hard can it possibly be? All you got to do is move 140 characters through our system. I'll get to it later. I'll show a few graphs of why this problem actually becomes one of the biggest pains in the neck that you can imagine. So what's the data structure of a tweet really look like? So let's use the one tweet that we pulled up earlier. So there are a few characteristics about a tweet. There's a person who sent it. There's a text about it. There's the date it was sent. And what it really comes down to, for those of you who know what like a map looks like, this is sort of a JSON representation of a data structure, that a tweet really just kind of looks like that. It's just a few specific fields that describe what goes into every single status update that goes through our system. There are a few more things that go there, but they're really tangential. Like, if you notice in the tweet itself, it has like the via txt, which says it came from SMS. We store that somewhere too. I sent a tweet, it says Twitter for iPhone is the source of it. Or if you send it from the web, it says the website. In some of our later tweets, so this is a tweet from 2008 before we had a whole feature suite around it. In some of our later tweets, you can geotag a tweet. So tweets might be like from the Berkeley campus, or from San Francisco, or from the Twitter headquarters lunchroom. So you can sort of narrow the scope down and sort of directionally broadcast your tweets. A tweet could be a reply. You could be talking to certain people. So you might be messaging back and forth. All this data needs to be stored somewhere. But when it really comes down to it, there are only 4 things that I really care about of what goes in a tweet. And this is the crux of what we need to move through the system. So that's a tweet. Where do they go? So once we have that tweet and the tweet I sent earlier, we need to figure out how do we route this through the world. So tweets need to go between people. Like, I'm going to send one, whoever's following me is going to receive it. So we have what we call an asymmetric graph. It's not something like Facebook, where Facebook you have to accept a friend request in order to start seeing them. Like, you're basically going to sort of say that like we're friends with each other is a mutual thing. Twitter is a asymmetric thing. It's not necessarily mutual. The power of this is that I can go and follow Barack Obama, and he doesn't have to go follow me back. Like, that's not going to happen in any other social network. But it also it's really similar to how email works, right? Like, I can send an email out. They don't necessarily need to have approved my email back to me. It also has really interesting properties. Like, when you actually look at our graph, our quote-unquote social graph is probably more of like an interest graph. It's people who produce content that I'm really interested in learning about, but they may not necessarily be interested in the content I'm creating. Put another way, if you look at all the people that I follow, so people like Tim O'Reilly, maybe Lance Armstrong, maybe Barack Obama, it sort of hints at what I'm interested in listening, or what I'm interested in about the world, what kind of information I want delivered to me. I might be following the bakery down the street because I want to know when the scones come out of the oven so I can go get them while they're hot. The really interesting thing about the asymmetric graph is if those people aren't following me back, it's a real good signal of what I'm interested in. So I may follow Judy. Judy probably follows me back because there's this social convention that she doesn't follow me back, I'll be really sad, we'll have a fight about it. But if Barack Obama doesn't follow me back, I don't care, right? So like that's a really good signal of like the interest of what I'm expressing in our network. And that's really what we think of our graph as like. It's less of a social graph and it's more of an interest graph. So we have the following and followed by relationship, right? I follow Judy, Judy is followed by me. But it gets a lot more complicated when we really start dealing with all the people that might be the recipient of my tweet. So I'm going to send a tweet, it has to go out to everyone who's following me. So tweets multiply through a system. I send a tweet in. One tweet in means more than one tweet out, usually. And of course, this gets a lot more complicated when you start looking at our entire graph. So we have something like 160 million users today, and every single user probably follows more than one person. Some users are followed a lot. Some users aren't followed followed at all, or maybe followed by one person. So our graph becomes this massive. It requires a massive database with a huge number of edges, more edges than we have people in the system to sort of compute how tweets need to traverse the system. OK, so that's how tweets get from point A to point B. When you're viewing tweets, tweets really show up in what we call timelines. So timelines are a ordered list of tweets that were generated. They're time sorted usually. So like I took this screenshot sometime yesterday. So like the Sandowski tweet is the most recent one that's on my timeline. Jess's is older than that. So tweets get, when they get sent out, they get what we call fanned into a timeline. So every one of you who has an account has a timeline that we call the home timeline. So all the people you're following, when they create a tweet, we fan those into your timeline. So if everyone in this room had a timeline, when I send a tweet, the system needs to go and put my tweet into everyone's timeline. So that's your home timeline. It's all the things that the people you're following have created. We have a few other timelines in the system. My user timeline, for example, is what I have tweeted. So if you look at Raffi's user timeline, actually, if you just go to like twitter.com/Raffi, you'll see my user timeline. It's all the tweets that I have generated in the system. The home timeline is the ones you followed. So the way we compute the home timeline is you take the user timeline of everyone that you're following and sort of like merge them together and then time sort them. So I take all of Judy's tweets, I take all of Lance Armstrong's tweets, I take all of Barack Obama's tweets, sort of slam them together into one list and sort them by time. And that becomes the timeline that I see on twitter.com. So it really ends up looking just like an array of numbers is what our data structure and our system looks like. We have one huge timeline service that all it does is keep a list of numbers in the system, and those are all the tweets. So that's what my home timeline looked like last night, for example. Those are all the tweets and their IDs of the tweets that showed up in my timeline. Everyone has something very similar to this. The velocity, or how fast it changes, depends on how many people you follow and how often those people tweet. Does that make sense? Cool. So is that it? Like, is that all of Twitter? Yeah. I mean, that's all we really kind of do. The real problem, though, becomes like, how do you actually make this work? So like, you can really envision that if that's all the system was doing, then you can run this on one computer. It'd be a fairly simple program. Like you go find some junior engineer that could probably whip it up in like a week. Probably do something close to accurate. But things get a lot more complicated when you have to deal with scale, and that's what I really want to talk about. Like what happens when a system gets really big, and what happens when it gets really big at the speed that Twitter is growing. And also, we have to take into the other constraint that Twitter is real time. So it's not like I have an option of when a tweet comes in that I'll deliver to you sometime in the next day or so. Like we really get tweets out in seconds. So if one tweet comes in, within seconds, I need it to go out to everyone who's following me. That's really kind of crazy when you think about it. Like email, Facebook, all these other ways of communicating, you don't have this real-time constraint. Real-time constraints are like telephones, right? Telephones don't necessarily correspond to the way the internet works. Like we've always thought about like sending an email, like someone might read it a few hours later, that's fine. If you send an IM, they may not be there, that's still fine. But for tweets, they really need to go in and out of the system as quickly as possible. So how many tweets are there? So I joined somewhere around here. So we were doing maybe 3 million tweets a day. And now we're around January 2010, we're doing about 50 million tweets a day. We recently released a new graph, which puts us out about 90 million tweets a day are going through the system. So that's really fast. Like this one tweet a second, or this one tweet that I'm gonna send out that needs to be sent to all my followers, sort of starts to sound a lot more difficult when you're dealing with 90 million a day. 90 million a day comes out to about 1,000 tweets a second. If you really think about that, that's actually a pretty astonishing number. That means 1,000 people in the world are creating a tweet every single second of the day. there are more people than there are in this room who are like pulling out a phone, bringing up a browser, or doing something and creating content, whether they're commentating on what they're seeing right now, whether they're replying to someone else or sharing a link through Twitter. It's 1,000 unique people every single second is sort of doing this. I think that's a baffling number. And then you have to remember that's only steady state. So that's 90 million tweets a day. So 90 million in 24 hours. So this 24 hours divided by 60 to get tweets a second. So that's steady state in the system right now. But the system is almost never at steady state. One of the slides we like to show is this is what the World Cup looked like at Twitter. So that number of tweets a second is somewhere around here. Like if you look at these spikes in the background, that's the number of tweets a second we're receiving throughout the World Cup. So the steady state is somewhere around here, about 1,000 tweets a second. You can see we peaked somewhere around 3,200 tweets a second during one of the goals in the World Cup. And this just really starts to show like how people are talking in Twitter and how it corresponds to the real world. Like when something happens, it's simultaneously happening on Twitter. When Michael Jackson died, Twitter got really sad. when the plane went down the Hudson River, people were tweeting about it like crazy from New York City. It sort of propagated. You can look at what the propagation wave of information really looks like. All these things are just sort of how the system reacts to the world. Like there are great war stories that I like to tell around the World Cup. So like engineering would be sitting at their desks, and all of a sudden the system would be really slow, and no one knew why, like what sort of happened. But the first instinct of any engineer who's worked at Twitter for more than a month is if the system's acting really funky, you ask, who died? Or like what just happened in the world? Like why are all these people tweeting all of a sudden? Like we know what the standard curve looks like. So there's like a sine wave that goes on throughout the day and through the week. So like 11 a.m. Pacific or 10 a.m. Pacific is probably where we get the most tweets coming in every single second. And that's because it's a really bad convergence of time zones. Around 10 a.m. Pacific is East Coast is at lunch. The East Coast, like New York City, is also in the same time zone as Brazil. Brazilians love Twitter. 1 p.m. Eastern is around 7 p.m. London time, so that means all the British are out drinking, so they're all tweeting. And then, and then this sort of goes around the world. Like Japan is sort of like wrapping around. They're all going to bed. Like they're all basically saying good night at that point. And then us West Coasters are just going to work. So like 10 a.m. Pacific is really the worst time in our system because everyone in the world is just talking right there. And you can sort of see it sort of dip down. So we hit the dip basically when the world shifts over to Indonesia-ish area. But Indonesia is coming up right now. So like we're losing the trough. It's sort of climbing up to the peak because Indonesians really love Twitter too. They love their BlackBerries, and because they love their BlackBerries, they love Twitter. It's kind of a remarkable thing. But then this also goes on throughout the week. So like most people, like you can see there's a big peak of tweets on Monday when people are like, this is what I did this weekend. And then there's a big peak on Thursday when they're like, let's go out drinking tomorrow, or like this is what I'm going to do this following weekend. So you can sort of see that sinusoid. There's like a real dearth over the weekend. There's a dearth around the midweek, and those peaks show up there. So engineers know what the system is going to look like, is what I'm trying to say. Like we've seen it enough times. We've seen it on a day-by-day basis. So when we see extraordinary events, then we know something went on in the world. Again, during the World Cup, like you just predict when a goal occurred. In fact, engineering spent this entire time rooting against the wrong team. Like so you root against Japan because if the Japanese score, then all the Japanese people are going to start tweeting, which is going to make our lives a little hellish for a few minutes. So you're sort of like rooting against the wrong teams to just sort of like survive the World Cup. It's a very difficult time. So I showed this graph earlier. So like there's the delivery mechanism. So like tweet comes in, tweet goes out. And like I said, tweets multiply. For me, every single time I tweet, as of last night anyway, 5,162 people need to get my tweet and need to get it in a couple of seconds. That's a hard problem, right? I need to look up all 5,000 people, pull their timeline, stick my tweet in their timeline, store it to a disk or store it to memory so that when they ask it, they can get the data. But that's sort of amateur hour when you look at people like this. Like these three are some of the top 3 biggest in the system. Like So every time Lady Gaga decides to say something, 6.8 million people need to get that tweet. Justin Bieber is 5.7 million. Barack Obama is 5.6. What's actually most depressing about this slide is the last time I gave this talk, Barack Obama was above Justin Bieber. So that makes me kind of sad. And then there's like puny me here at like 5.1 thousand followers. But so like delivering my tweets sounds trivial when you think about all the big people we need to also deliver at any given time. And what those numbers really sort of illustrate is like we have a massive scaling problem just on tweet delivery. So like the difference between me at 5.1 times 10 to the 3 followers and Lady Gaga at 6.8 to times 10 to the 6 followers is a 10 to the 3rd difference of just the number of people who are following you, just like tweet delivery. So it really means that scaling the system, our graph needs to scale to like on the order of 10 to the 6 on just deliveries of tweets that are coming into the system. So if you look at that, 10 to 6 deliveries a minute comes out to about 6,000 deliveries every millisecond if you're delivering it on a minute basis. We might slew that a bit more. Like it might take us like a few minutes to deliver someone like Lady Gaga or a few minutes to deliver like the president's tweets. But these numbers are just baffling. Like you can't do this on one machine anymore. Like we have a large cluster of machines which not only integrate with our timeline service, but every single time a tweet is sent, that might cause a message to go out our streaming server. Our streaming server is connected to Google. Google gets all the tweets that are generated in real time. So whenever Lady Gaga tweets, it has to go out to Google within a second, is I think what we consider our service agreement with Google. But it also means that lots of people probably follow Lady Gaga via SMS. So we have to integrate with all the SMS providers in the world in order to start blasting SMSs out. In fact, right now, Twitter is the largest SMS generator in the world right now. We generate more SMSs than anyone else does. The number of SMSs we send to AT&T alone in the US is a baffling number. We might generate an email when a tweet is sent. Like all these need to happen within a couple of seconds of the tweet being generated. It's pretty kind of a crazy problem. And this is only on one user. So you can imagine a worst case scenario of when Kanye West goes on a rant and starts tweeting every minute. We need to look up all the people who are following Kanye West every single time he tweets, because it may have changed since the last time he tweeted. Like someone may have gotten thoroughly annoyed by listening to a rant and may have unfollowed him. So we need to look up the graph every single time he tweets. We need to blast out that message every single time he tweets. So this just really means we're starting to create large queues of tweets that are coming in the system, and they need to be flushed as quickly as possible and get out into the world. But when you're starting to build a system like this, the one thing you really learn is that it's really the weakest link that becomes your biggest problem in all these scenarios. So one of our weakest links, I'm not going to say it's our weakest link, is just a hard drive. So does anyone know what these numbers mean? So like at steady state, if you get a hard drive spinning, you can write about 80 megabytes a second to it. In order to find a spot on a hard drive, so like a hard drive stores data spread out amongst this platter, in order to find stuff on a hard drive, it takes about 10 milliseconds to spin that thing and find it on average. So that's a physical limitation that we have to engineer into our system. These are numbers that we sort of live and breathe by because it really affects our scale and our real-time delivery constraints. If we had to seek every single time we needed to deliver something to a user, we can only do 100 seeks a second on every single hard drive. We're getting 1,000 tweets a second right now, and it's growing. We need to deliver it to, if it's Lady Gaga, 6-point-something million people. Like we can't do this on one hard drive anymore. You can't do this on one computer anymore. So we have massive arrays and massive banks of servers just dedicated to tweet delivery and tweet storage, so we can fan this problem out and distribute it. And you also have to worry about things like what happens when one of those servers crashes or dies. Like the meantime, like I've had this laptop for about a year and a half now. I change laptops every 2 years, every 3 years, give or take. Something probably breaks. So the meantime to failure of my laptop is on an order of 2 years. When you have thousands of machines, it means that every single day, more than one of your computers are breaking. So we have to build that kind of consideration into the way we design our system, that every single day, portions of our data center are just breaking on us, and we're going to need to replace it. So we need to construct for redundancy. So if we can't just simply have one server which is all of Lady Gaga's followers, because that machine's probably going to break sometime in the next year. We need to have multiple of those servers. We need to have multiple of everything in our system. Like, I can't survive. Like, there's a requirement on my team that everything be logged and everything be able to be analyzed later. If one of the hard drive crashes in one of our machines, I can't use that as an excuse to why I don't have data anymore. I need to have made sure the system is organized so all this data is spread out amongst the cluster. Do all of you know what a database is? Give or take? It's a way of organizing information either in memory or a hard drive. It's a way of giving it structure. So we've been using something called MySQL for the longest time. MySQL is an open source database. It uses a language called SQL to actually do the way that you organize and query information that goes into it. The biggest problem with something like MySQL, and the largest websites in the world use MySQL, Google even uses it in some cases, Facebook uses it also, is that at the rate that tweeters are creating data, MySQL can no longer store it for us. Like, MySQL just can't accept data at the speed that we're generating it anymore. This has become a problem for us. It's no longer just hard drives. There's something called an ID on every single tweet. Those are numbers that you saw. The way we had it before is when a tweet comes into the system, we'd ask MySQL, what's the next ID we should give this tweet? So every single time a tweet comes in the system, you ask MySQL, give me the next ID, give me the next ID. But it means that we now have a single point of failure in our system. There's one place that's generating the IDs for us. And when we found out, we can no longer generate them fast enough. At the speed of tweets come in, MySQL is becoming our bottleneck. So what we had to do is we created a system that we call Snowflake. And Snowflake's whole job is to generate IDs for us really quickly. In fact, we can, on our Snowflake cluster right now, we can generate about 10,000 IDs a second. So we have a little room to grow. Right now, we're having about 1,000 tweets a second. Our peak is at about 3,000 tweets a second. So we have about 7,000 tweets a second to grow. But this also illustrates the other challenge of working at some place like Twitter, is that you build the system you know how to build today, and you build it for some foreseeable future. So like the team leads usually pick, like, is it 6 months, is it 2 years that you're building the system for? You can't build the perfect system. Like, if you had the fullness of time, you would go build the exact system, the exact right system for this problem. But I don't have years to build a solution. Do you have a question?
Yeah, what are IDs?
Oh, sure. So like every single tweet, like the first tweet in the system has an ID of 1, for example. A current tweet in the system has an ID of maybe 70 billion. I can't remember the exact number off the top of my head. So we do something like 90 million a day. We've been running for a couple of years. So each one of those tweets just gets an ID, which is the identifier. It's the latest number that shows up. So before, just to rehash, MySQL was generating those identifiers for us. And MySQL can no longer do it fast enough. At 1,000 tweets a second or 3,000 tweets a second, MySQL just can't do it anymore. So Snowflake is what does it for us. Like, these are really the kind of challenges that we tackle every day of us. Currently engineered systems no longer match the scale we're moving at. And you build the system you know how to build. Like, we built Snowflake. It'll probably last us for a year or two. We might have to revisit this problem, but we just don't have the time and the resources to figure out the best solution for that problem. Something else is bound to break in that time. We have to go focus over there for a while and get that system working for a year or two. And we'll come back to this problem later. It's sort of building the best system you can.
If you keep growing exponentially, when are you going to run out of 64-bit?
The projection on 64-bit integers puts us pretty far out. That's not necessarily something we're concerned right now. Just to like rehash that issue. So right now, all our IDs in the system are 64 bits. 1 byte